vapor pressure, and relative humidity. Pressure exerted by molecules of vapor is called vapor pressure. Vapor pressure could be unsaturated or saturated. An unsaturated vapor is vapor which is not in contact with its own liquid in a closed space. Saturated vapor is a vapor in contact with or in equilibrium with its own liquid. Saturated vapor pressure of a liquid increases with increase in temperature, and the relationship between the saturated vapor pressure and temperature is indicated by this graph. Relative humidity is the ratio of the mass of water vapor present in a certain volume of air to the mass of water vapor required to saturate the same volume of air at the same temperature. The hygrometer is used for measuring humidity. A small temperature difference between the wet and dry bulb thermometers of the hygrometer indicates high relative humidity, and vice versa. Relative humidity is equal to vapor pressure of air divided by the saturated vapor pressure at the original air temperature times 100%. We can also calculate relative humidity depending on the available information using again saturated vapor pressure of water at dew point divided by saturated vapor pressure of water at the original air temperature times 100%. Example 1. When the temperature difference between the wet and dry bulbs of a hygrometer is high, this indicates that A, it is about to rain, B, there is plenty of sunshine, C, the relative humidity is low, D, the relative humidity is high. The answer to the question is as follows. The temperature difference between the wet and dry bulbs of the hygrometer is an indirect indication of the relative humidity at the given time. Temperature difference between wet and dry bulbs of the hygrometer measures the relative humidity. When the difference in temperature is low, the relative humidity is high. And vice versa. From this statement of facts, going through the options, we find out that the difference in temperature of the hygrometer bulbs, when it is high, it is not an indication of rain about to fall. A is wrong. It does not tell Whether there is plenty of sunshine. B. Wrong. The relative humidity is low. That's the correct answer. Correct. Of course, D is wrong. Example 2. If the partial pressure of water vapor at 27 degrees Celsius is 18 millimeter mercury and the saturated vapor pressure of the atmosphere at the same temperature is 24 millimeter mercury, the relative humidity at this temperature is A. 25%, B. 33%, C. 75%, D. 80%. The solution to this example is as follows. Relative humidity is equal to vapor pressure at the given temperature divided by the saturated vapor pressure at the same temperature. Times 100%. So relative humidity will now give us 18 divided by 24 times 100%. 6 here will give us 3, 6 here 4. 300 divided by 4 will give us 75%. By this calculation, option C is correct.